In this video, we're going to convert between z-scores and data values. Find the z-scores or data values for the given normal distributions, round to 2 decimal places as needed. So in this first set of problems, we're told that a set of data is normally distributed, the mean is 80, and the standard deviation is 12. We're asked to find the z-scores for the following data values and interpret your results. Okay, so here's our formula for z-scores. Okay, and let's just try to get a sense for what this means. Okay, I'm not a great drawer. That wasn't a bad normal curve. So we're told the mean is 80, so that's in the center. The standard deviation is 12, so we'd have 92, 104. Again, not to scale like the pretty computer pictures, at 12, 116. If we went 3 standard deviations to the left, it would be 68. Minus 12 is 56, and minus 12 is 44. So this is the mean, plus 1, plus 2, plus 3, minus 1, minus 2, minus 3. Okay. So what a z-score is telling us is it's giving us a value that tells us the number of standard deviations the data value is from the mean, but it's not just going to be integer values, it could be decimal values. Okay, so when it says take the data value and subtract the mean, okay, that's the same as we could think of shifting that, but it's the difference between the data value and the mean. So if we had 68, for example, that difference is 12, and it would actually be negative since 68 is less. So we find the difference between the data value and the mean, and then dividing by the standard deviation tells us how many standard deviations that difference is. Well, we'd have negative 12 here, divided by 12 is negative 1, which gives us our result. Okay, but now we can have values somewhere in between. Okay, so and it's important to know how to compute these, but also try to get a feel for what the values represent so you can have number sense about the distributions. So the first one is 83, so that's in here somewhere. Okay, so that's going to be between 0 and 1 standard deviations from the mean. To find the exact value, we have 83 minus 80 divided by 12. That is 3/12, which is 1/4. It's 0.25, but they asked for a decimal, so we'll just do it on the calculator. 0.25. So the interpretation is 83 is 0.25 standard deviations above the mean. Okay? And it's above the mean because the z-score is positive. Okay? If you get a negative z-score, then that would mean it's below the mean. Okay? So the next one, 74. Let's see where this is. Well, this is below the mean. It's in here somewhere. So let's see, I don't know, about there-ish. Okay. And again, I'm just getting a feel for it. So z-score for this equals 74 minus 80 divided by 12. And let's do this whole thing. Oh, this is going to be a nice one too. But let's do this whole thing on the calculator just so you know for when the numbers don't come out so nice. Make sure you either subtract first, hit enter, and then divide, or you can put it in parentheses. So 74 minus 80, close parentheses. So it's 6 to the left of the mean. Since the standard deviation is 12, that's 1/2 of a standard deviation to the left of the mean. So negative 0.5 is the z-score. And our interpretation is 74 is 0.5 standard deviations below the mean. So when we interpret it, we like to use positive numbers for the standard deviation, and we differentiate between the signs by saying whether it's above the mean, positive z-score, or below the mean, negative z-score. Okay. Based on what we've done so far, where do you think 96 is going to be? Well, I know it's above the mean, so it's going to be positive. It's between 1 and 2 standard deviations. 96 lives in here somewhere. Okay, now let's compute it exactly. So z equals 96 minus 80 over 12. Okay, and this is 16 over 12. We could do this by hand, but just for practice, since these are integers, they're turning out kind of nice. 96 minus 80 in parentheses, that's 16. So it's 16 away from the mean. And how many standard deviations is that? Well, how many 12s are in 16? And rounding to 2 decimal places, 1.33. So it's 1 1/3 standard deviations, but rounded it's 1.33. Okay. And we interpret that as 96 is 1.33 standard deviations above the mean. Okay, and now let's look at 50. So let's see where 50 lives. So 50 is going to be between -2 and -3 standard deviations in there somewhere. And to find it exactly, we find z equals 50 minus 80. Okay, so that's our difference from the mean. It's 30 below the mean because it's -30. How many 12s are in 30? And we'll start from the beginning. 50 minus 80 divided by 12 is -2.5. So 50 is 2.5 standard deviations, since it's negative and it's to the left of the mean, below the mean. Okay. Now we're going to look at the reverse direction. Okay. We're given z-scores and we want to find the corresponding data value given a different distribution. So here we're told that the mean is 20 and the standard deviation is 4.5, and we want to find the data values for the z-scores. Okay. So reversing this idea, let's make a little curve again. So the mean is 20, the standard deviation is 4.5, so I'd add 1 standard deviation, 29 is 2, and 3 would be 33.5. Okay. If I went to the left, this would be 15.5 is 1 below, 11 is 2 below, and this would be 6.5. Okay. So this is a sketch of the curve. Remember, this is the mean. The mean is 0 standard deviations from itself. Then we have +1, +2, +3 standard deviations, -1, -2, -3 standard deviations. Okay, so when we're finding a data value, okay, since the z-score tells us how many standard deviations it is from the mean, you multiply that by the standard deviation and add it to the mean. Okay, so z equals 1.26. That's going to live somewhere in between here. Okay, because that's 1 standard deviation and that's 2. Okay, so using the formula, the data value, let's call that dv, take the mean of 20, and then we want to add on, the z-score is 1.26, so this is 1.26 standard deviations from the mean, so it's 1.26 copies of, that's multiplication, of 4.5. Okay. And we'll do this on the calculator. So it's the mean plus 1.26 times 4.5. So 25.67. And let's just take a look. That seems right. It's between 24.5 and 29. Let's look at the next one. Z equals -0.8. So that's going to be below the mean, not a full standard deviation, but somewhere around here. Okay, so it's going to be between 15.5 and 20, closer to 15.5. Okay, so we're going to take the mean. Okay, now I'm going to put addition here. We can also use subtraction because this is negative, and that's what we'll do on the calculator, but I want to follow the formula. The z-score is -0.8, and the standard deviation is 4.5. Okay, so notice adding a negative is the same as subtracting a positive. So when I do the negative ones, I find it easier to just do 20, negative ones meaning negative z-scores. Instead of doing plus, this product's going to be negative, so I'll just do minus 0.8 times 4.5. And we get 16.4. And let's check. That seems reasonable, okay, because it's between 15.5 and 20. Now z equals 2.33. Well, that's going to be between 2 and 3, around here somewhere. So between 29 and 33.5. The data value is 20 plus 2.33 standard deviations, where a standard deviation is 4.5. So we start with the mean and add 2.33 standard deviations, and we get 20 plus 2.33 times 4.5 equals, and we'll round that to 30.49. And our last one, we have z equals negative 2.4. So that's 20. Oh, we didn't find it. Negative 2.4 lives about here. So between 6.5 and 11, looks closer to 11. So 20 plus negative 2.4 times 4.5. And again, I'm going to use subtraction and then make this positive. 2.4 times 4.5 is 9.2. And that matches our approximation.